All right. So Unit 6A is about characterizing data. Okay. So what we're looking at here is ways to look at the actual data that we collect. All right, so the distribution of data set. Distribution of a variable or data set refers to the ways its values are spread out over all of our possible values, okay? And this distribution can be shown visually within a table. And we looked at this a couple of class periods ago. Tables could be frequency tables, or it could be a graph, a histogram, okay? So let's go through some important definitions. So first of all, what is an average? 3 common ways to characterize the center of a data distribution. I'm sorry, there are 3 ways to characterize it, okay? All of which are sometimes called the average. These are also known as your central tendencies. Okay, so first of all, your mean. Your mean is a data set that's equal to the sum of all of your values divided by the total. Okay, so mean is add all your values up and then simply divide by the total number. Mean is also known as average. The median is the middle value. Okay, you want to make sure that you put your data in order first, and then you would simply cross out until you get to the middle. Okay, your mode is the most common value, the number that pops up the most. All right, let's look at an example. 8 grocery stores sell an energy bar for the following prices. And you're giving your prices here. We're being asked to find the mean, the median, and the mode for these prices. Okay. So the first thing, the mean. Remember, your mean means that we add all of our numbers up and divide by the total. Okay, so we can simply take the numbers, add them all up, 1.49 plus 1.29 plus 1.79 plus 1.09 plus 1.39, 129, 135, and 159. Oops. Okay. And then we divide by the total that we have. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to divide that by 8. And we get our mean is $1.41. Okay. The median. Remember, our median is our middle number. So the first thing that we have to do is take our numbers and put them in order. Okay. So if we look at our data, we look for our smallest number. I see 1.09. And I'm going to cross them out as I use it to make sure that I have everything taken care of. So 1.09 and then 129. I have 2 of those. Mm, 139, or actually 135. So 135, then 139. $149, $159, and then $179. Okay, 1, 2, 3, 4, 5, 6, 7, 8. I always just double check to make sure I haven't forgotten anything. So that median means that I cross out until I get to the middle. Okay, so I'm starting at the front and the back. Cross out again, cross out again. And in this case, and remember my support students, we talked about this yesterday. If we have 2 middle numbers, and that occurs when we have an even set of data. If we have 2 middle numbers, then we have to find the average of those 2 numbers, okay? And so we would say 1.35 plus 1.39 divided by 2. All right. So 1.35 plus 1.39 divided by 2. And so our median is $1.37. And then our mode is the number that pops up the most. And so when our numbers are in order, we can see which one we see the most of. And you'll see here that mode is going to be $1.29. Okay, questions there? Okay, just to review, we talked about yesterday in support how you can put this data into a list, okay, and have the calculator come up with that data set for you as well, okay? And I'll go through it quickly, but if you don't remember, you can look at the video from yesterday, or you could also go to the folder for support and the instructions on how to put that in the calculator are there as well. Okay, but on your calculator, you would go to Stat, press Enter on Edit. And since I have data in my list, I'm simply going to go to the top of it, press Clear and Enter. And then I'm going to put my data in. It does not have to be in order. So I simply type it in, 1.49, Enter. 1.29, Enter. Okay. If I scroll back on my last number, I'll see that I have 8 numbers, so I'm good. Okay, so then I go to Stat again. I use my right arrow and arrow over to Calc. I press Enter on number 1, which is a 1 variable stat. Make sure that my correct list is being shown, and it is. My data is in list 1. And then I arrow down and calculate. Okay. So here we were being asked to find the mean. Remember X bar, that represents our mean. So our mean is 141, which is what we figured out when we did it by hand. Okay, the next thing is the median. So if we arrow down, because we have an arrow there, we'll see the median right there, MED. Median is 1.37, and that's what we figured out. The mode you're going to have to figure out yourself. That's not given to you in a 1 variable stat. Okay. Questions there? Okay. All right. So what if there was an odd number of pieces of data? Okay. So let's remove the largest price and find the mean, median, and mode now. Okay. So I want you all to take a moment and do that. So this is your new data set. The largest number was removed. I want you to take a moment and find the mean, the median, and the mode. Okay. So your mean should have been $1.36. Your median, $1.35, and your mode, $1.29. Any questions on how we got any of those numbers? Okay. All right, continuing along, outliers. So an outlier is a data value that is much higher or much lower than almost all of your other values. An outlier can change the mean of a data set, but it will not affect the median or the mode. All right, let's look at an example. A track coach wants to determine an appropriate heart rate for her athletes during their workout. And so she reads the following heart rates on a monitor: 130, 135, 140, 145, and 325. I want you to take a moment and calculate the mean and the median. Okay, so you should have gotten the mean to be 175 and your median to be 140. To get the mean of 175, we simply added all of our numbers up and divided by 5, okay? And then your median, if you look at your numbers, they're already in order. So all you had to do was cross out until you got to the middle, which is 140. Everybody okay with that? Okay. So let's think about our data values and answer the question, does there appear to be any outlier? So remember, an outlier is a value that's either really higher or lower than all of your other values. It was see an outlier.
$325.
Yes, thank you. So yes, we do have an outlier of 325 because it just doesn't fit with these other numbers. So we're going to take that number out and then recalculate our mean and our median. So we now have 130, 135, 140, 145. Okay, so if we calculate our mean now by taking the outlier out, we will get a mean of 137.5. So we added up all those numbers. So 130 plus 135 plus 140 plus 145. And we have 4 numbers, so we divide by 4. We get 137.5. Our median, we have 4 numbers. So our 2 middle numbers are going to be 135 and 40. So if we add 135 plus 40 and divide by 2, our median is 137.5 as well. Okay. So now if we look at what we've come up with, what value do you think would be a better average for this data set? So I know it's the same, but if we look at what we had before and what we now have, do you think the mean or the median would be a better average?
Median.
Very good, exactly, median. The median was not affected by the outlier, okay? And what I mean by that is up here, we had a mean of 175, right? With the outlier. When we took the outlier out, that mean reduced drastically, okay? But our median is pretty much the same, pretty close, okay? And so that's why the median would be a better average to use. Okay, questions there? Okay, let's look at another example then. All right, a newspaper surveys wages for assembly workers in regional high-tech companies, and they report an average of $42 per hour. The workers at one large firm immediately request a pay raise. They're claiming that they work just as hard as employees at other companies, but their average wage is only $36 an hour. The management rejects this and tells them they are overpaid because their average wage is in fact $48 per hour. Can both sides be right? And explain. Okay, I'm gonna give you a minute to read over that yourself and process it, and then we can talk. Okay. All right, so one way to think about this, let's consider these as wages that the employees are being paid. Okay, so they're being paid, one person is being paid $36, another is 36, another is 36, another is 36, and then you have a wage of $96 an hour. Okay, so if we take this data, we will see that the mean is 48. Okay. We'll also see here that the median, we cross out until we get to the middle, the median is $36. Okay, so let's think about what was said up here. So the employees said, no, we're only getting paid $36 an hour. But then the management said, that's not right. You all are getting paid $48 an hour. So based on what we just calculate, can both sides be correct? Yes, they can. Okay. It depends on what definition is being used for average. Okay. So in the case of the employees, they're looking at the median range. Okay. If we look at all of our data set, these are probably going to be your assembly workers. Okay. And more than likely this $96 here, what do you all think that, whose wage would that be? What do you think this $96? If these $36 an hour represents the assembly workers, who do you think this $96 per hour would represent?
The boss or like the manager.
Right, yeah, the boss or the manager, exactly. Okay, so if we are taking into account the boss or the manager as well, then that mean is $48, right? But if we look at our median as our average, then now we have a better indication of, okay, on average, what are the assembly workers making? Okay, and so that's where we're getting the $36 an hour. Well, management didn't take that into account. They looked at the mean, in which they added everything up and divided by the total. And so the mean here is 48. So to answer this question, yes, both sides can be right. Okay, it just depends on what definition you're using for your average. Any questions there? Okay, let's look at another example. Suppose I took a survey of a class and asked, what is your yearly income? So I asked, what's the yearly income? I noted all of those incomes. Then I calculated the mean, median, and mode. Okay. But what if then Bill Gates walks into the room? How would this yearly income affect our previous central measures? And what central measure do you think is a better one to use when our outliers are being involved? Okay, so I took data from everyone and came up with their yearly income. Okay, calculate the mean, median, and mode. But then Bill Gates walks in. Okay, I ask him what his is. How is the central measures affected? How are they affected? Excuse me. That means what happens to them?
Surely Bill Gates becomes an outlier.
Very good. Yes. So Bill Gates is an outlier. And what does that do to our data?
It's going to raise it to
The mean, yeah, the mean will raise drastically, right? Will it necessarily affect our median though?
no.
Right, exactly. Because remember that median, all we're doing is adding Bill Gates' number to the mix. Of course, it's going to be over here on the end. Okay. And so the middle number is not going to change much. Okay. So what central measure is the better one to use when outliers are involved? Would it be the mean or would it be the median? It would be the median, okay? Because remember that outlier, if we add it in, the outlier is going to make our mean increase. So that's not something that we want to use when we're looking at central measures. Okay, any questions there, guys? Okay. Y'all aren't very talkative this morning. Thank you, Trisha and Sarah, for working with me though. All right, let's talk about shapes of distribution. Okay. We have 3 different shapes of distribution, which we're going to look at. And remember, it might not be as exact as your sample data, but it's going to approximate it in some manner. So a shape of distribution is if you were to line out your data, okay, what type of shape would it create? So the first one is called symmetric. Symmetric is if the left half is a mirror image of the right half, okay? And I've told you all before, I'm horrible with drawing, but I'm gonna try my best here. Okay, if you've heard of a bell-shaped curve, that's what symmetric means. So the left half is a mirror image of the right half. That means it is symmetric. Okay, that's what this distribution would look like. Okay, then you have left skewed. This is if your values are more spread out on the left side. We also call this a left tail. So kind of look like more spread out on the left side, okay? So we have more data here, and so that's why we call it a left tail. And then we have if our data is right skewed. And this is when our values are more spread out on the right side. We call that a right tail. Okay. So kind of look like this. All right. So in a skewed distribution, the median is a better measure of the center of the distribution. So kind of think about it. Here, if we're symmetric, that means we have the same amount of data values on the left side, that means on the small end, as opposed to the right end, okay? So we have small, large, about the same amount. That's why we call it symmetric. If our data is left skewed, then we have more data values on the lower end, on the left side, okay? If it's right skewed, then we have more data values on the right side, okay, on the larger end. And so in a skewed distribution, it's better to think about the median as your measure of the center of your distribution, okay? Because again, we think about outliers. Okay, so let's look at some examples. For each of the situations, state whether you expect the distribution to be symmetric, left skewed, or right skewed, and then we're going to explain. Okay, so the first one, heights of a sample of 100 women. So think about if you were to randomly sample 100 women, what do you think those heights would look like? And so in this case, our distribution would be symmetric, okay? And it would be symmetric because, again, we're randomly selecting 100 women. So that means we're going to have some that are going to be short, we're going to have some that are average, and we're going to have some that are tall, okay? So we would roughly have an equal number of short and tall women. Okay. Now, what if I was to go to a gymnastic gym? Okay. How do you think the data would be skewed then? So if I, instead of just randomly selecting 100 women, if I go to a gym where girls are practicing gymnastics, how do you think the data would be skewed then? Would it be symmetric, left skewed, or right skewed? Anyone? So who do we think, what type of girls or women do you think we would find at the gymnastics gym? Would they be tall? Would they be short, medium height? What do you think? Okay, guys, y'all making it difficult. Y'all talk to me, we can get out. How do you think it would look? Tall, short, medium height? So generally, girls that compete in gymnastics are going to be short. And so then our data in this case would be left skewed, okay? Because remember, left skewed means that we have more data points on the left, on the smaller end, okay? All right, what about B? Number of books read during the school year by fifth graders. Number of books read during the school year by fifth graders. So in this case, I would say that this one is right skewed. Okay, and think about it. Most fifth graders are probably going to read an average number of books. Okay, so average. You'll have a few who are going to read more, right? And you'll have an outlier, but for the most part, it's going to be right skewed. Okay, so we'll be here, more people on the right side. Questions there? All right. So variation. Variation describes how widely your data values are spread about the center of distribution. When your distribution is symmetric, your mean and your median are equal. So here we have a low variation because our data, remember, variation shows how the data values are spread. So here we have low variation because they're not spread about that much. Okay, they're kind of clustered here. Here we have moderate variation, and this shows high variation. Okay. So let's look at this example down here. It says, which has the most and least variation? So if we look at A, which is in green, B, which is in blue, C is in red, and D is in yellow. Your most variation is going to be D, okay? Because if you look here, it goes from here to here. So that means your numbers are going to vary significantly more. So your most variation is going to be D. And then your least variation would be B, okay? Questions there? Okay. All right, last example. Says, how would you expect the symmetry and variation to differ between times in the Olympic marathon and times in the New York marathon? And let's explain. So we're still talking about variation.
I wouldn't expect much variation in the Olympic marathon because most people have to qualify. But the New York marathon, that's just anybody who wants to join. So that would have a lot of variation.
Excellent. Very good, Trisha. That is correct. And that's a perfect explanation. So yeah, so if we think about the Olympics, as she said, yeah, people are having to make a qualifying time. So that means in the Olympic marathon, these are competitors and they're all going to be within the same amount of time. You know, maybe a small variation, maybe if someone, you know, ends up hurting themselves in the middle of it or something. But for the most part, yes, their times are going to be roughly the same. So the data will cluster together. Whereas in a New York marathon, yeah, you can have some people who've been training for years, you know, some who are just coming out for the first time. And so, yeah, here you would have more variation. Okay, good job. All right, any questions there? Comments?